The software quality assurance component has been designed to address the activities that are required to ensure that software developers do it right the first time. SQA encompasses basic quality philosophy, technical tasks, and organizational approaches. This component is presented in 3 modules: software quality, SQA activities, and software reviews. This module, Software Reviews, introduces an activity that many believe to be the most important of all software quality assurance tasks. During this module, we'll consider the structure of a formal technical review, the people who participate in it, and the guidelines that should be followed to make it effective. And now, Roger Pressman on formal technical reviews.
We all make mistakes, even when we try hard not to. I make a classic mistake whenever I send out an important business letter. It seems that I check it once or even twice, send it out, and then, sadly, recognize that a typo exists. It doesn't often happen, but it does happen. Try as I might, I see what I meant, not what I wrote. That's part of the reason for formal technical reviews in software engineering, to allow us to examine the software, models, programs, data, and documents in a way that enables us to examine what we did rather than what we meant. A formal technical review is a pivotal software quality assurance mechanism. It enables a software engineering team to improve the quality of the software at every step along the software engineering process. A formal technical review is a meeting for technical peers conducted by technical peers. As Jerry Weinberg said, there is no particular reason why your friend and colleague cannot also be your sternest critic. In fact, that is the focus of a formal technical review, to conduct a meeting in a way that finds errors. The formal technical review is a generic term that describes any number of structured meetings. A structured meeting, quite simply, is some organized approach at getting people together to achieve some end result. Now, when we talk about the formal technical review, we generally use 2 different names: the walkthrough or the inspection. Formal technical reviews are conducted throughout the software engineering process flow. Software engineering reviews are conducted during analysis, during design, during coding, even during testing. They're conducted after software is released to the field, whenever a change is requested. They are the single most important quality assurance mechanism that we have. Recall earlier when we talked about the cost to find and fix an error. The sooner we do it, the less expensive it is. It's arguable that the only option we have for finding errors early is the review. Reviews satisfy a number of different objectives and can be described from a number of different perspectives. As I've already noted, reviews are a technical meeting conducted by technical people for technical people. The specific intent is an assessment of the work product that's been created during the software engineering process. Reviews are the most important software quality assurance mechanism, and very importantly, reviews are a training ground, enabling software people to learn about the product that is currently being produced and to see examples of both good and bad software. But it's very important to also understand what reviews are not. Reviews are not a project budgetary summary. They're not a status meeting or a scheduling assessment. And they are not an overall progress report. Most importantly, reviews should not be a mechanism for political intrigue or reprisal. Formal technical reviews if performed correctly, can be extremely effective as a quality assurance mechanism. They will help you to uncover errors in the work that you're doing. Just remember what they are and what they aren't. Reviews are a filter. Okay, they're one of the many quality assurance filters. If you look at the pictorial in front of you, what you see is a representation of reviews. A water tank, dirty water contained in the water tank, a pipe flowing out of the water tank. What we want to do is flow the water through the pipe, and when it comes out the end, have it be crystal clear so that we can drink it. The obvious solution. The obvious solution is to have clean water in the tank to begin with. But lacking that, assuming that some degree of dirt will be in the water, there is a second obvious solution. And that simply is filter the water. So, we have some options. We can put a single filter in the flow. Some dirt will be removed from the water. The water will flow through the pipe and come out, but it still will have a dusky feel to it. I'm not sure we really want to drink it. Well, there's another option. We can put dozens of filters in the flow, hundreds of filters in the flow, coarse filters, fine filters, medium filters, ultraviolet filters. Finally, the water flows out, and it's beautifully crystal clear. What's the problem? Reviews are filters in the software engineering flow. We could, I suppose, have reviews every 10 minutes. And likely, if we took them seriously and conducted them properly and recorded the results and acted upon them, we would get very close to defect-free software coming out at the other end. But there's a price to pay for that. And the price to be paid is simply that the flow of the software engineering process would be rather slow. So we have trade-offs. What reviews should we put into place? How many of them should there be? What types should there be? Well, those are issues that you need to address when you talk about formal technical reviews. These questions about reviews are not easy to answer because they'll vary from project to project. What reviews do we put into place? Reviews that focus on analysis and analysis models, design and design documentation, the code itself, and in many instances, test plans and procedures. How many of them do we put into place? Enough so that we ensure that quality is maintained as the software engineering process proceeds. And what types of reviews should we conduct? What are our options? Well, that leads us to the next section of this module. Reviews can be conducted at a number of different levels of formality. At the lowest level of formality, we can simply conduct a casual meeting around a coffee machine or in your office. The intent of the meeting is to discuss some software issue. No records are kept, no specific agenda is defined, but in fact, we may gain some useful information out of the meeting. Moving up the formality spectrum, we can conduct a project review, talking about status or schedule, about problems encountered, and solutions offered. This is a form of review, but it is not the type of review that we're talking about in this ESE module. Moving upward still, we can define a formal presentation. Here we present the software to a large group of people and receive their feedback on potential problems or difficulties. This is another form of review, but still not the type of formal technical review that we need to achieve high-quality software. Finally, at the top of the formality spectrum, we can conduct either walkthroughs or inspections. These are formal technical reviews. An agenda is defined, records are kept, action items are identified. In fact, these types of reviews provide us with the strongest possible software quality assurance mechanism. Reviews fall along a broad spectrum. There is significant evidence that indicates that the more formal the review, the more likely it is to uncover errors in the work. There is also, however, significant evidence that indicates that the more formal the review, the more people that are involved, and the more time it takes. None of this should come as a shock to you. That's kind of intuitively obvious. What is the best approach to conducting reviews? How should we conduct reviews so that we have a reasonable likelihood of uncovering defects and still maintain reasonable flow rate in the software engineering process? If a formal technical review is to be effective, people have to meet and they have to communicate. This is essential to get the job done. But the concept of a meeting presents us with a problem when we think about formal technical reviews. I'll bet in your experience, many of the meetings that you've attended simply don't work very well. And this can present a problem. If a review is a meeting and meetings don't work very well, we better define formal technical reviews in a way that avoids some of the problems of the typical meeting. Before we proceed, spend a moment actually making a list of reasons why general meetings don't work. List things like lack of preparation or no agenda. There are many others. Make a list and then we'll proceed. I suspect if you've attended as many meetings as I have, that you've developed a fairly lengthy list. Among the entries may have been a lack of preparation by all involved, a lack of leadership, no defined leader for the meeting, and therefore a lack of an agenda or the ability to control the meeting in an effective way. You may have the wrong people present or too many or too few people. You may have drift during the meeting, causing time to be wasted on needless activities. The facilities for the meeting itself may be inappropriate. There may be too many interruptions or too much noise. Individuals who participate may have a hidden agenda and not go to the overall objective of the meeting. Timing may be bad, and in fact, the participants may not create a record of the meeting. No action items are maintained, and therefore, no positive actions occur out of the review. All of these things are problematic. And if we are to conduct effective formal technical reviews, all of them have to be eliminated when we establish review guidelines. All of these things represent significant problems in conducting effective meetings. If you took an effective meetings course, whether you realize it or not, you also took a significant portion of an effectives reviews course. You need to know more, but basically, conducting an effective review is also conducting an effective meeting. When one establishes review guidelines, one must establish those guidelines in a way that circumvents the problems that we've just talked about. As we've seen, effective meetings, and therefore effective formal technical reviews, have many things in common. Among them is the idea that everyone who participates in the review plays a specific role. Let's examine the roles of formal technical review participants in some detail. There must be a review leader. You can call that person a moderator, a facilitator, a manager of the review, a review manager, whatever you'd like. But the bottom line is there must be somebody who controls the flow of the review. During the time that the review exists, that person has dictatorial authority to maintain agenda, to shut down side conversations, to redirect discussion, to reconcile conflict. That person is the leader. Okay. Number two, we have the producer. The producer is the person who created the product that is being reviewed. We must have somebody on the review team whose job it is to be a reviewer, but also to write down any salient issues that are uncovered as part of the review. The recorder is a reviewer. The review leader is a reviewer. The producer is a reviewer. And there may be others who are reviewers. That makes up the review team.
Dr. Pressman, what is the best size for a review team?
Well, it's a little bit difficult to state this, unequivocally, because obviously there are situations where more or fewer occur. But the best size teams that I see tend to be in the range of 3 to 5 people. Very small, very small. But if in fact you're looking, and that's a function of what the scope of what you're looking at is. If in fact you're looking at a larger scope, you may have to draw in more expertise to get the right view. I guess if I were to say an optimal review team, you're kind of putting me against the wall here, I would pick the number 4. The 4 people who participate in a formal technical review, the leader, the recorder, the producer, and the reviewer, can be augmented with others. It might be possible to include a software quality assurance representative to ensure that all standards compliance has been checked and that standards are being maintained. We might include a representative from the user organization in reviews where user-specific information is relevant. And finally, we might include representatives from the maintenance organization to make sure that decisions made during the review will not adversely affect the long-term maintainability of the system. These and many other people can be added to the review team. But overall, we should try to keep the team as small as is reasonably possible to conduct an effective review. It's now time to consider the review scenario itself to determine how we define a set of rules for actually conducting a formal technical review. Although every organization puts its own spin on formal technical reviews, there is a basic scenario that's almost always present. First, review materials must be distributed to everyone who is going to participate in the review. And in fact, the review must be scheduled and facilities must be lined up in a way that allows people to participate easily. Advanced preparation must occur, and when the review meeting commences, the leader should take action to be sure that drift does not occur, that an agenda is maintained, that a recorder takes notes, and that the reviewers raise issues in an appropriate fashion. The review team has to meet or reach consensus at the end of the review. And based on this consensus, records must be kept through a technical review summary report so that a final record of the review is maintained. All of these things represent a basic scenario. But it might be worthwhile to take a look at this scenario in just a bit more detail, to look at it in terms of a simple cookbook. Let's do that now. The walkthrough begins this way. The producer completes some product as part of the software engineering activity. It might be a portion of a specification, portion of a design, some source code, a test plan, whatever. The producer goes to the project leader and says, I've completed this product. I've gone through it myself. I think it's ready for a review. Okay. The project leader says, okay, why don't you go to Sally Smith? She's going to be the review leader for this particular product to review. Why don't you schedule a review with her? The producer goes to Sally. Sally takes a look at the materials to be reviewed, just to make sure they're legible and reasonably complete, scans them quickly and says, okay, let's see whether we can set up a review for tomorrow, which is Thursday, at 10 o'clock. I'll contact a couple of other reviewers and see whether that's a possibility. Why don't you give me a copy of the product so I can get copies made for the other guys? Sally distributes the product to each of the reviewers. The reviewers are expected to spend between 1 hour and 2 hours reviewing the product, annotating it, red penciling it, making notes prior to the review. Prior to the review. Now, 1 to 2 hours is not a lot of time. The implication of that statement is the amount of stuff that we give to the reviewers is relatively low, small, and that therefore it is reasonably focused. We do not drop a 300-page requirement spec on their desk and say, here, review this in an hour and get ready for a review tomorrow. That's not how formal technical reviews work. They work in bits and pieces. The reviewers prepare offline prior to tomorrow's meeting. Meanwhile, Sally, the review leader, is doing the same thing. But in addition, as she goes through the document, she's also writing down potential agenda topics, okay? Because it's her responsibility to establish at least a preliminary agenda. Night passes, next morning occurs, 10 o'clock comes, everybody appears at the appointed place, a meeting room. The meeting room should be comfortable, large enough to accommodate the attendees, no telephones, good AV potential, good lighting, etc. Sally gathers the group together. Likely everybody knows one another. They're all working on the project team. She begins formally. Thanks for coming, everybody. We are here today to conduct a walkthrough for the product at hand. Our intent is to try to uncover potential problems or errors in the product so that we can act on them and correct them. Words to that effect. I put together an agenda. She passed it out. I'd like each to scan it quickly. If anybody has any recommendations for change, let's address that right now. People scan the agenda. Maybe somebody raises their hand and says, gee, Sally, I really don't think we spent enough time in this agenda you're showing here talking about the data structures. Let's assume it's a design. Okay? And I really think we probably ought to spend a little bit more time. And Sally will think about that for a moment, look at it and say, okay, yeah, I think we can probably push maybe a little bit more time to there. We'll try to cut a little bit more time off the end. The agenda usually spans between 1 and 2 hours.
Dr. Pressman, why is it that everyone can be expected to be free at 10 o'clock?
Organizations that do this well do the following. They establish time blocks during the week that are what are called review time blocks. No other meeting or activity can be legitimately scheduled during those time blocks. It can be Tuesdays and Thursdays from 10 to 12 and 2 to 4. It can be Monday, Wednesday, and Fridays from 10 to 12. It doesn't matter what it is. But in essence, those are sacrosanct. No other meeting or activity, no other site visit or anything else can be scheduled during that time. Now, of course, that's violated. People travel, emergencies come up, etc. But that helps a lot in getting folks to be available for reviews.
To this point, we've talked about preparation. Now let's spend some time talking about what happens during the review itself.
Returning to our review meeting. The review then begins. The producer begins to walk through the product. I don't mean literally read it, but I mean just talk about each section or each model or each segment of code, depending on what we're looking at, and say, this is what our intent was, this is what I was trying to do here, this is the overall focus. As the producer walks through the product, the reviewers will raise issues. They'll make comments, they'll ask questions. The recorder is writing down anything of relevance. Now, ideally, the recorder is writing this down, possibly using something like an overhead projector, where literally everybody can see what that person is writing down. Or they might use a flip chart or a whiteboard or whatever. I mean, the bottom line, it's a good idea for people to see what the recorder is writing down, just so that everybody stays tracked. Discussion ensues. Action items are noticed, or are noted. And ultimately, the agenda is tracked. We come to the end of the meeting. The last agenda item in the meeting is always the same, and it is determination of status. The review team must come to a successful decision on what happens next. In most walkthrough approaches, there are 3 different possibilities. 1, the material reviewed is acceptable. No errors were found. Okay? Standards have been maintained. If that's an agenda item, it's acceptable. 2, the product under review is acceptable with minor modification. What that means is minor errors have been uncovered. They are established as action items. They must be addressed by the producer, but no subsequent review is required. Lastly, the item is unacceptable as presented. And you can use more politic words if you prefer. Serious errors have been found. Modifications will have to be made to address those serious errors. And another review will have to be conducted to ensure that side effects have not been created as a consequence of these major modifications.
Dr. Pressman, does an inspection differ from the walkthrough that you've just discussed?
Now, an inspection is subtly different. Same scenario, same basic players, but we add a few. There is a facilitator who takes on the role of leader and who sometimes does not participate as an active reviewer, just simply takes on the role of the leader. There is a reader. The role of the reader is to serve as a surrogate producer and literally present the material under review. But the reader is not presenting it with any preconceived producer's notions, if you understand what I'm saying. They are presenting it literally because that's what they're seeing. The producer can inadvertently mislead the review team because the producer is seeing what he or she meant, not necessarily what he or she did. The reader will present what the producer did. When problems are found during an inspection, they are typically recorded specifically and categorized by type. Now, this leads us to the potential of statistical QA that we talked about a while back. But the rhythm, the agenda, the requirements, the guidelines all remain the same.
As you've already learned, record keeping is an essential part of an effective formal technical review. We maintain records throughout the flow of the review itself. And when the review team finally comes to a decision at the end of the review, we have to maintain one additional type of record. We complete something called a technical review summary report, which identifies the final decision that the team has made and lists the action items associated with the review.
They come to a conclusion. That conclusion is noted on a summary sheet. Everybody on the review team signs the sheet, just as engineers sign schematics, okay, to sign off on quality. The technical review summary sheet is attached to an action item list, and it becomes part of the project record. An organization should have
review guidelines that are published and available and read by everybody. The review guidelines should define the basic review scenario. The review guidelines should define basic style issues. The review guidelines should also address best approaches for interpersonal issues in reviews. The review guidelines, in fact, should really cover some of the topics that are just kind of outlined on this slide right here. You know, they should emphasize the need to be prepared. They should really emphasize the need to recognize that people are involved in this activity. And you are reviewing the product, not the producer. Your tone, your style, the questions you ask, the overall approach, even your body language should focus on making people comfortable, not on making people uneasy.
In addition to the need for preparation and the recognition that people are involved in formal technical reviews and egos must be considered, it's also important to consider some other review guidelines. First, we have to stick to an agenda, and that means that the review leader has to control things effectively. During the review, we raise issues, but we don't necessarily have to resolve them. That is, the formal technical review is not a problem-solving session. We should, as already stated, avoid discussions of style, and we have to consider formal technical reviews as project tasks, scheduling them just as we would any other project task. Many people think about these guidelines and worry that there may be hostility or anger during the review. This is, in most cases, an unfounded concern. The vast majority of formal technical reviews proceed smoothly, without people becoming angry or getting into arguments. This occurs if good review guidelines are established and strong leadership is maintained.
Dr. Pressman, I've heard that some review teams make use of checklists. What do you think about that?
Checklists are a form that are used in the inspection approach. I have mixed emotions about checklists. On the one hand, I think they're very useful because they allow people to cover issues in an organized fashion and possibly cover things that they might have forgotten about. So from that point of view, I think they're very useful. The downside of checklists is people tend to review to the checklist. And if the checklist doesn't consider something that's relevant to it, people may just be led astray with it. You know, well, they're just going down, you know, like that, almost like, you know, an automotive inspection when you get a new car. You know, sometimes there's problems with it because it wasn't on the checklist and nobody cared about it. Well, the same thing can happen in a review. So I have mixed emotions about them. I certainly don't think that there's any problem with them. I just think, again, common sense has to prevail. You have to have your checklist, but then you say, now let's consider other issues.
Dr. Pressman, when we conduct reviews, we often get bogged down in discussing the elegance or style of the solution. Are we headed in the wrong direction?
In a software review, in a formal technical review, either a walkthrough or an inspection, the primary focus isn't on determining style or approach to a problem. That can be done in other ways in other kinds of meetings. The primary focus is solely to find error with what has been done. In other words, it is out of bounds in a formal technical review for software engineering to say, well, that works, but I wouldn't have done it that way. Response is, who cares? I mean, the person did it the way that they felt was most appropriate. If it meets requirements, if it is correct, if it's unambiguous and error-free, we let it run. You don't get into discussions of style, because that's where the 10 to the 20th problem comes out. Obviously, there are a lot of different ways to implement software. And if you begin to get into discussions of style, you're dead. Because then people's backs go up. They, you know, you have all kinds of difficulties and personality issues. You stick strictly with issues of correctness.
Dr. Pressman, what if someone raises issues associated with the long-term maintainability of a work product undergoing review? That's a style-related issue, isn't it? How do we handle this kind of situation?
If a person makes a comment that says, I have some questions about the maintainability of this, you know, I see no error, but I have questions about the maintainability of it, and there's some discussion, and another person says, well, no, I think it's fairly solid, the review leader immediately shuts it down and it says, what I'd like to do is note it as an item in our action list, that there is some question about maintenance, but I want that addressed outside of this meeting. Okay, and we won't consider it directly in terms of our judgment on the piece, since it is correct and does work. That's the way you handle that. So instead of getting into a lengthy debate about what is maintainability, what isn't maintainability, which is somewhat subjective, I don't deny, you shut it down and say this should be addressed outside of the meeting.
Should an FTR focus on standards compliance?
There is debate about whether or not a review should focus on standards within some companies and within some organizations. Let me explain what I mean. Many instances, software engineers, when they conduct formal reviews, want to focus primarily on technical content. And they say, we'll let a QA organization review separately to examine conformance to standards. You can make your own judgment on whether or not that's an efficient way to proceed. Okay? But there is that ongoing debate that occurs. You know, who should look at standards? Should it be the software engineers? Should it be the QA group?
In most human endeavors, good things happen when strong leadership is applied. And formal technical reviews are no exception. The role of the review leader is pivotal to a successful review. As Weinberg and Friedman state in their excellent book on reviews, the job of the review leader is to obtain a good review, or to report the reasons why a good review was not obtained. It turns out that the overall job of a review leader actually focuses on both preparation and control. The review leader prepares by collecting all relevant product materials from the producer of the materials. The review leader schedules the time, the place, and the people for the review, and photocopies and distributes product materials for advanced preparation and review. The review leader studies the product materials and sets an agenda for the review, and double checks reviewer preparation and facilities prior to the actual initiation of the review. All of these things happen before the review is conducted. But what about the review itself? That leads us to control. The review leader controls the review by setting the agenda and assessing advanced preparation to ensure that everybody is ready to provide constructive criticism during the review itself. The review leader maintains an even pace so that drift doesn't occur and interrupts all unproductive discussions, essentially following the guideline that states that we raise issues, we don't necessarily resolve them. The review leader polls the reviewers for consensus at the end of the review to determine a decision based on the work product. And finally, the review leader ensures that good records are kept throughout the review and that a technical review summary report is maintained at the end of the review. In essence, the review leader leads. Without this individual, a review will drift and will likely be ineffective.
Dr. Pressman, is there a difference in the role of the review leader in a walkthrough and in an inspection?
In a walkthrough, the review leader is an active participant in the review. In an inspection, which is what we're talking about here, the review leader doesn't have that name. The review leader is called a moderator or a facilitator. And the reason for that is the review leader does not actively serve in the role of reviewer. He or she simply is the facilitator or moderator, and therefore can kind of separate himself from the ongoing discussion in the review. Both review approaches are effective. It just depends on which one an organization chooses to use. The most effective approach is an inspection. But the problem is, an inspection tends to absorb a bit more resource. So sometimes people don't use it and opt for a walkthrough. Either can be very effective.
The producer is an active participant in the formal technical review. And by this I mean that the producer presents product material and explains his or her approach as the review proceeds. In a walkthrough format, the producer actually walks individuals through the document or the program that's being reviewed. In an inspection, this activity is performed by someone called a reader, but no less, the producer participates in the review. The producer also answers questions and clarifies when questions are asked, but never should the producer take on the role of a hostile witness. Recall that the reviewers are reviewing the product, not the person who produced the product. Finally, the producer is a reviewer. It may be that during the review, the producer actually sees something that wasn't seen earlier and points out an error that nobody else saw. All the better. The recorder maintains a written record of all issues raised during the review. But why is this so important? The answer lies in things falling into the cracks. Unless a written record is maintained, it's likely that folks will forget the issues that were raised during a review and that some of them won't be addressed after the review. That leads to an ineffective quality assurance mechanism. It's for this reason that the recorder is so important. The recorder is selected by the review leader prior to the initiation of the review meeting. In some cases, the role can be divided among two people. And in every case, notes should be made available to all reviewers in a contemporaneous fashion. In order to achieve this, unconventional note-taking may be required. For example, it might be useful to use a flip chart to maintain review records rather than a sheet of paper. In some cases, transparencies and a projector can be used so that everybody can see notes as they are being taken. A wallboard might be an appropriate mechanism, or it might even be useful to photocopy written notes on a piece of paper and distribute them during the review itself. The reasons for this are obvious. It's important that each reviewer see the issues as they are being recorded to ensure that proper interpretation of the issues is being made. Everyone on the review team, the leader, the producer, the recorder, the reviewers, and anyone else who participates is, in essence, a reviewer. And that means that everyone on the review team should prepare in advance, should apply sensitive criticism when examining errors in the work product, and should work toward a consensus opinion at the end of a review. The review team is not a jury, and the producer is not in the witness stand. The formal technical review activity is designed to help improve the quality of the end product. And that's the role of each reviewer on the review team.
Dr. Pressman, should managers participate in reviews?
In many organizations, the formal technical review is conducted only at a technical level. No managers participate. Okay? And the reason for that is simply so that the review does not begin to take on the feel of a personnel appraisal.
We have a quality engineering organization at our shop. Should a quality engineer attend every review?
When and if a quality engineer does attend a review, The role of the quality engineer in general is to serve as an auditor, to ensure, among other things, that action items are being properly maintained, that there is some assessment of standards compliance and guidelines compliance, that in fact the review itself is being conducted in a manner that, that will result in the highest probability of uncovering errors. And if the quality engineer has the technical background, skill level, and relevant knowledge, they can also serve to contribute as a reviewer themselves. But I am not a firm proponent of having a quality engineer participate in every walkthrough or every inspection. I think the role of the formal technical review, the walkthrough, or the inspection is a role that should be performed by the project team. They are as much a member of the, quote, quality team as the quality engineer is.
If you care about software quality, you'll soon be participating in formal technical reviews, if you're not doing so already. But in order to be an effective participant, you must prepare. Let's examine your approach. First, you have to understand the context of the material that you'll be looking at. And if you don't understand context, you should go to the producer to find out just where this material fits into the bigger picture. You should first skim the work product to understand the location and format of all information that's relevant to the review. Next, you should read the product material in detail and annotate the hard copy so that you'll be organized when you raise questions during the review. You should, at all costs, avoid issues of style, focusing on errors in the documents or code that you're examining. And finally, if you can't prepare, you should inform the review leader so that someone can be appointed to take your place. All of these things are part of advanced preparation for the reviews. But what if you're the review leader? How can you determine whether other reviewers have, in fact, prepared? Part of the answer lies in observing the reviewers as the review is conducted. Here are some of the things you should look for. Is a reviewer reading during the review rather than participating? Are most of the reviewers' comments Me Too comments rather than comments that add something to the collective knowledge? Is a reviewer nitpicking or philosophizing rather than contributing in an effective manner? Is the reviewer making real-time notes on the work product, notes that should have been made prior to the review? And finally, is a reviewer filibustering, focusing on only one topic because apparently that's the only topic that he or she covered during preparation? As a review leader, if you note that a single person hasn't prepared, likely you can allow the review to continue. But if a number of reviewers show signs that indicate that they have not prepared, it's better to cancel the review and reschedule it once preparation has been completed.
There's always a concern when reviews are conducted that there's going to be lots and lots of conflict. And there really isn't if they're conducted properly, and if people are properly trained and introduced to this idea, and if everybody is signed up to the fact that there is absolutely no shame in having a review team find problems. You really should be happy about that. There's no shame in that. Everybody screws up. Everybody screws up. The shame is in letting the problem sneak through.
Not all reviews are conducted by software engineers. In fact, there's a variation on formal technical reviews called a software quality audit, which is often conducted by software quality assurance people with the intent of examining the procedures that lead to high quality. Let's examine the audit for just a few moments.
Dr. Pressman, can you explain the difference between formal technical reviews and SQA audits?
Whereas the formal technical review is in general conducted by software engineering folks for software engineering folks, a quality audit is conducted by the QA group for the customer. Okay? The point being, the QA group is going to certify that those quality assurance activities called out in the quality plan are in fact being conducted. What are some of the things that, that a quality audit would look for? It would look for evidence that formal technical reviews are being conducted. It would certainly look for evidence that standards and procedures are being followed. It would certainly look for evidence that good software engineering practice and a solid software engineering process are being applied. If, in fact, measurement is dictated, it would ensure that the appropriate data are being collected. Okay? It would be sure that tests are being planned, and it would audit those test plans for completeness and consistency. And it would take a look at action items. Action items derived as a consequence of formal technical reviews, and action items derived as a consequence of the result of testing. And it would ensure that action items that are noted have been appropriately acted upon, and when necessary, re-reviewed.
Dr. Pressman, should we audit everything?
Do you do an audit on everything? Of course not. Okay? SQA resources are limited. Probably the most effective auditing mechanism is a sampled audit. It works well in manufacturing. There is no reason why it shouldn't also work well in software engineering work. We simply look at examples, at artifacts on some sampling basis, and work under the assumption, which is a reasonably good one, that if some small sample exhibits high quality, it is like random sample, I might add, exhibits high quality, then likely all artifacts will exhibit some degree of quality. And the converse, sadly, is also true. If a random sample has major quality problems, it is likely that the entire software configuration will have quality problems.
Regardless of the software engineering paradigm that you choose when you establish your software process model, it's important to note that you distribute reviews evenly throughout the process. For example, in the slide before you, you see an evolutionary process model that includes planning, risk assessment, engineering, installation and support, customer evaluation, and customer communication as major framework activities. You'll note that review density is greatest during the engineering activity. This is as it should be. It's during engineering that we build quality, and therefore it should be during engineering that we carefully assess quality through the use of formal technical reviews. But it's important to recognize that we conduct reviews at other places throughout the software process. We conduct reviews during installation and support, even during customer communication, and potentially during planning. The reality is that reviews act as exit conditions that enable us to invoke each software process activity with the assurance that quality will be maintained.
If an organization is serious about improving its process, there are metrics that can be collected to indicate the efficacy of formal technical reviews. What are some of them? Inspection time per page of documentation. It's interesting to know how much effort is being expended per page. Okay? Inspection time per 1,000 lines of code, looking at it after the fact. Why would you want to collect these data? Well, one thing is it'll help you estimate how much review time you should be allocating to new projects. Secondarily, it'll begin to give you a feeling as to what percentage of overall project budget is being allocated to reviews on a given project. The defects uncovered or errors uncovered per reviewer hour. Okay, that's kind of interesting. The errors uncovered per preparation hour. The defects uncovered per software engineering task. Where are you finding defects? Because in fact, if you are conducting reviews during a particular task and their average error find rate is very low, you have to ask two things. Number one, maybe you shouldn't be bothering with reviews here. Or two, maybe you're going to have to improve the way in which you're conducting reviews during this activity. But you need to know this. As you collect information on errors, you might want to also record the number of minor errors found during reviews per review hour per 1,000 lines of code, the number of moderate and possibly major errors that are found. Yes, you would make a distinction between a typo, which is a trivial error in some situations, like in a document, it's a trivial error in general, and a severe design fault, for example, that would have resulted in enormous cost and problems later on. Okay? So sure, you can make a distinction between the severity of an error. There's absolutely no problem with that. Okay? These kinds of data can provide you with insight into whether or not the review process is working.
How can we determine whether reviews are effective?
Really what you have to do is build up a bit of a database on this. And you have to relate these data to the DRE for projects. See, again, all of these things begin to come together. You're looking for projects that resulted in high quality product. What were their numbers for this? Okay. Then we look at projects that resulted in lower quality products. What were their numbers for this? Is there a correlation? If there is not, and there may not be, there may be other factors that affected it. All I'm suggesting to you is that you can be more systematic about the way that you're looking at things.
The effectiveness of software reviews can also be determined on economic grounds. If you instrument your software process, it shouldn't be too difficult to determine the cost of an average error or defect, the cost required to find and correct an error found during a formal technical review, and the costs associated with finding and correcting the same error if finding and correcting it is delayed until testing. The inequalities that you see on this slide will provide appropriate justification for conducting formal technical reviews. During this ESE module, we've spent some time talking about the most important of all software quality assurance mechanisms. We've talked about the objectives, the options, the scenario, the players, the guidelines, and the measures associated with formal technical reviews. As I mentioned earlier, if someone were to put me against a wall and ask for one SQA activity that would provide maximum benefit, it would be the formal technical review.
This concludes the video portion of this ESE module. Please refer to your ESE component workbook for the module post-test and recommendations for further readings and exercises. If you're unsure of any topic presented in this module, return to the videotape for another look. After you've completed reading and exercises in the workbook, you'll be ready to proceed to the next ESE module or component.